All right, so I just wanted to make a little message to tell you guys good luck on your test and that I love you all. You are ready, and I know you guys are gonna do your best. If you want to make a 3 or 4 or 5, then I would definitely recommend looking back over the free response questions we practiced, maybe practicing old free response questions. You can find them on the internet really easily, and you can find the answers. So you still have today and this weekend to get ready. But come in on Monday and be confident that you know what you know, and you're going to do great. So I'm going to do this little 5 for 5 review with you. So I would like for you to be with your normal partner, unless you just really, really want to do this by yourself. It doesn't matter to me, really. But you might have a piece of paper if you want to jot something down. But this is a 5 for 5 final review, and 5 for 5s are usually written so if you get 5 questions right, then hopefully you can make a 5 on the AP test. But the questions do get more difficult as you go through. Maybe, maybe not. The 5th one is definitely the most difficult on this one. So anyway, so with your partner, I want you to decide if these are true or false. And so the first one is that if g of x is concave up, then using the tangent line at x equals 3 to approximate g of 3.1 will produce an overestimate. So g is concave up. Is the tangent line going to produce an overestimate? So take a second, make that decision with your partner. Okay, so hopefully you guys said false. So if we think concave up, and we'll say 3 is about right here, and we draw the tangent line. That tangent line will be equal at 3, but everywhere else it's going to be less than 3. So if we use this line to make a prediction, it's going to be a little bit too small. All right, so hopefully you guys got that. All right, let's look at number 2. Selected values of the derivative of a twice differentiable function f are shown in the table. And what we want to know is there a we want to know true or false. F has a relative minimum at x equals 2. So discuss that with your partner, see if you can figure it out. I just want to remind you before you make a final decision is we don't really know what's happening between these values. So between 1 and 2, we could actually change direction many, many times. So keep that in mind when you're deciding. All right, so if you still don't know, pause it. If not, I'm hoping that you guys said true. And it's because of the second derivative test. So we do know, because f prime is 0, that 2 is a critical number and that it could be a possible maximum or minimum. We want minimum. But like I said, we don't know really what's happening in between. But we do know that it's a critical number, and we also know that the second derivative is positive. And so it is true by the second derivative test. F prime of 2 is 0, and f double prime of 2 is positive, which means we're concave up, which does create a minimum. All right, there's that one. All right, let's look at number 3. So if g of x is the integral from 3 to x squared of f of t dt, then g prime of x is f of x squared. True or false? All right, so if you need to pause it and talk some more, go ahead and pause it now. So this is going to be false. This is a fundamental theorem of calculus, but the fundamental theorem of calculus works if this is just an x. You can just replace it there. So because it's an x squared, it's the fundamental theorem of calculus with an extra step. We are gonna do f of x squared, but because it's x squared and not just x, we have to multiply by the derivative of x squared. All right. Okay, let's look at number 4. If a curve is increasing, then a left Riemann sum gives an overestimate of the area under the curve. If you still need a minute to discuss, I'll go ahead and pause the video. This should be false. So I would highly recommend that you just draw increasing. It can be concave up, it could be concave down, it could be straight. The only one you can't do a straight line is if you're trying to determine if a trapezoidal sum is increasing or decreasing, and that you need to know the concavity. But a left or right Riemann sum, you can just draw a straight line if you want to, and then draw a little left rectangles, and you can tell that there is space under the curve that's not going to be accounted for, which is going to make this an underestimate. Okay, one more to do. Okay, so we want to know if the integral of f prime of 7 minus 2x dx is equal to negative 1/2 times f of 7 minus 2x plus c. So this one is probably going to take you a minute. Alright, so I'm going to give you a hint. If you don't want it yet, then you can pause the video. But the antiderivative of a derivative of something does just change it back to the regular function. But this one does have this negative 1/2 here. And so you need to look at this and decide if there should be a negative 1/2 there. Alright, if you're not ready, pause the video. If you are ready, then this is definitely true. Alright, now I'm going to go through the whole U substitution process so you can see it. But we can also do just a little bit of a shortcut. So I'll show you both ways. So because this is a function inside of a function, we can say that u is 7 minus 2x. And then du dx is going to be negative 2. And then you can solve that for u. Okay, and so we need a negative 2 dx. However, we only have a dx. So we would correct that by multiplying by negative 2. And then in front, we would multiply by negative 1/2. And then we're going to change this to u's. So f prime of, and then in the place of 7 minus 2x, we're going to put u. And then in the place of negative 2 dx, we're going to put du. Right? And then, like I said, the antiderivative of a derivative just changes it back to the function. And then we would go back and put the 7 minus 2x in for u. Okay, so that will work. A lot of times, though, what I think, especially if I'm trying to save time, is whenever we're finding the integral, and this is an expression, it's not just x, if the derivative of it is just a number, we can figure out the antiderivative without doing the whole u substitution. As long as that number is negative 2, we multiply by the reciprocal in the front. So I think some people that still hasn't sunk in, and that's okay. If you want to do u substitution, it's fine. It's possible u substitution still hasn't sunk in, and you'll just do your best. I trust you guys. I trust you all to work your best, your hardest on this test, and I'm not worried at all. I know you guys are going to do great. So I will see you all next week. During the rest of this class period, I want you to go through the flashcards on the Quizlets that are posted in this lesson. You can do that together, or you could do that by yourself, whatever you want to do. But good luck on your test, and I am rooting for all of you.